Okay, what if I told you there's a type of liquid you could literally run across, punch like it's a solid, and then just watch it melt back into a puddle? I know, it sounds like something out of a sci-fi movie, but it's totally real, and we're about to break down the weird science that makes it all possible.
It really all comes down to this one kind of baffling question. You've probably seen those videos, right? People just sprinting across a pool filled with what looks like goo. How on earth is that possible? Well, the answer is found in the very strange world of non-Newtonian fluids. All right, before we get to the really weird stuff, we've got to get on the same page. What even is a fluid? It's not just a liquid. It's actually any substance that can flow. So yeah, that includes things like water, but it also includes gases, like the air we're breathing right now. Now, most of the fluids we deal with every day are what scientists call Newtonian. You can just think of these as the normal ones. Their big thing is that they have a constant viscosity, which is just a fancy word for thickness or resistance to flow. No matter what you do to them, their thickness never changes.
I mean, think about it. Water, milk, oil. It doesn't matter if you stir them slowly or you blend them up really fast. Their basic thickness is always the same. Water is just always water. It's simple, it's predictable, and it follows the rules.
But, and this is where things get really, really cool, some fluids just don't follow those rules at all. They behave in ways that seem to completely defy logic.
And here it is, side by side. The core difference is actually super simple. For normal Newtonian fluids, that thickness or viscosity is constant. But for the weird ones, the non-Newtonian fluids, their viscosity is variable. It literally changes depending on how much force you apply.
This is the key idea right here. It's this wild paradox. If you push it slowly, it flows and acts just like you'd expect the liquid to. But if you hit it with a sudden hard force, bam, it instantly resists and acts like a solid. It's like a substance with a total split personality. And the absolute classic, the superstar example of this, has got to be oobleck. You can even make this stuff at home with just cornstarch and water. It's that simple. It's this amazing goo that perfectly shows off this bizarre property.
Right about now, it probably feels like magic. But of course, it's not magic, it's just really cool physics. So what is actually going on? How does a simple mix of cornstarch and water pull this off?
The secret is all happening at the microscopic level. See, in oobleck, you've got all these tiny cornstarch particles just floating around in water. When you move slowly, the particles have plenty of time to just slide past each other. But if you apply a fast, hard force, like a punch, the particles don't have time to get out of the way. They just jam together, creating a temporary solid structure.
So there's a pretty cool scientific name for this effect. It's called shear thickening. A shear force is basically when you push one layer in one direction and another layer in the opposite direction, kind of like when you spread butter on toast. So this is a fluid that literally gets thicker when you apply that stress. And that is exactly what lets you run across a pool of it.
Okay, so you might be thinking, got it, non-Newtonian fluids get thicker under pressure. But hold on, because the story has another really surprising twist. Some of these weird fluids do the exact opposite.
This table lays it all out. On one side, you've got shear thickening fluids, like our friend oobleck, which get thicker. But on the other side, you have shear thinning fluids, which get thinner with force. And look at these examples. They're everywhere. Ketchup, paint, toothpaste, and get this, even human blood. In fact, our blood has to be shear thinning so it can flow easily through big arteries, but then thin out to squeeze through our tiniest little capillaries. It's literally a life-saving bit of physics.
And that's really the main point here. This isn't just some strange thing that happens in a lab. You interact with this weird science every single day, and you probably don't even realize it. Let's start with ketchup. You know that incredibly frustrating moment when it's stuck in the bottle? So you shake it and you smack the bottom, and then whoosh, it all comes rushing out at once. Yep, that's shear thinning in action. The force from the smack makes it temporarily thinner, letting it flow. Quicksand is a total classic from the movies, right? And it's a perfect example of a shear thickening fluid. If you stand still, it acts like a liquid. But the more you struggle and apply force, the thicker and more solid it gets, which is what traps you. What about toothpaste? Think about it. It's pretty thick in the tube, but when you squeeze it, when you apply that force, it thins out and flows really easily onto your brush. But then, once it's on the bristles, it stays put. It doesn't drip off. That's shear thinning at work again. So, we found it in our kitchen, in our bathroom, and out in nature. But what happens when scientists take this idea and start engineering with it on purpose?
Well, that brings us to the future, where this exact same science is being used to create some truly revolutionary tech.
Imagine body armor that's as flexible and comfortable as a t-shirt, but it becomes as hard as steel the instant it's hit. That is exactly what's being developed using these shear thickening fluids. And the same idea is being used to make smarter car shock absorbers, safer sports helmets, and even more advanced robots. This stuff is way more than just a cool party trick. It's the future of materials science.
Okay, so we've gone all the way from kitchen goo to life-saving body armor. It's kind of a lot to take in, so let's just do a super quick recap of the most important ideas.
It really all boils down to one simple question. Does the thickness change with force? For a normal Newtonian fluid, like water, the answer is no. For a non-Newtonian fluid, like oobleck, it's a definite yes.
And remember, that change comes in two main flavors. You've got shear thickening, where things get harder and thicker, and you've got shear thinning, where they get runnier. And this simple principle is at work everywhere, from the stuff in your fridge to the high-tech gear of tomorrow.
And that's really what I want you to take away from this. Our world is just filled with this incredible science that we usually take for granted. So the next time you're fighting with a ketchup bottle, you can just smile and remember, you're actually wrestling with a shear thinning, non-Newtonian fluid.
It really makes you wonder, doesn't it? I mean, if something as ordinary as ketchup follows such bizarre rules, what other incredible weird science is hiding right under our noses, just waiting for us to notice?